point on annuity, making use of a calculator. So I know that the formula itself can be a little bit a thing, but trust me, easily you can actually solve this just applying just a simple formula and boom, you have your answer. So you all agree with me that annuity is with respect to a series of equal payments made on an account, right? And when you hear the word series, that's with respect to sum of, right? Like sum of a sequence. So that's the reason why easily you can also use our summation to solve for questions on annuity. So now back to the question, we're told that a deposit of 15 naira is made on the first day of each month in an account that pays 6% interest compounded monthly. Meaning that we're introducing our M. When M represents numbers of times, it's being compounded within a year, right? So we're told to find the balance in the account after 2 years. So, okay, now back to this. The first thing for you to do is to determine what to be putting at the center of the summation. If you've watched our previous video where we talk about finding some of the end term of a sequence using a calculator, if you remember that when we talk about this, when we make reference to this part here, so this is what we're about to look for, articulate. So for this, you'll be making use, you'll be applying the formula for your compound interest. You all agree with me that for compound interest, we all know that our future value is equal to P into the bracket 1 plus R raised to power N, when P represents our principal, otherwise known as our initial deposit. R represents our ratio, our rates are B, large rates of interest, and N represent numbers of years. So this is for normal compounding, like whenever it's compounded annually. But if it's not compounded annually, that's us introducing M, right? So you're having P into the bracket 1 plus R all over M raised to power NM. So this is not going to be applying. This is the fact that it was compounded more than once in a year. It was compounded monthly. That's why we're using our M. So for what to fit at the center, we'll be using this. But the only modification that we'll be doing here is that the power here, that's our NM. Let me write the summation. Our NM will just change to X. That's just the modification. So you either, instead of writing, having NM here, I'll be having P into the bracket 1 plus R all over M raised to power X if it is annuity due. So this is for annuity due, and your upper limit, that's your what you're going to have there will be your NM. So that both of them will kind of swap. So upper limit now you'll be having it as NM, and the power here, which was initially NM, will actually have to change to what X, as simple as that. So let's fit in the blanks. So if here, back to the question, we're told that a deposit of 50 naira is made on the first day. So our principal here is 15 naira, right? Of each month, whenever deposit is made at the beginning of a period, we say it is what annuity due, right? That is why we're applying this formula. So we're told that it pays 6% interest compounded monthly in the sense of our rate is equal to 6%, and 6% is the same thing as 0.06. And we're also told that it was compounded monthly in the sense of our M equals to 12. We have 12 months in a year. Then we're told to find the balance in the account after 2 years. That's our N equals to 2. So applying this, our principal, that is the 15 naira into the bracket 1 plus our rate, that's 0.06, divided by in our M, that's 12, then raised to power X. Then here you're having your X equals to 1. In the sense, I'll start from the first year, then down to the upper limit is NM, that's your 12 times 2, that's 24. That's what you're having as your upper limit, as simple as that. So this is exactly what you are going to input in our calculator. Boom, we have our answer. So now let's input that. Imputing that, so our shift and our log, we have our summation, then we have 50. Please take note, we have a bracket here. Everything you are imputing here should be inside this bracket. It shouldn't be outside. Every element here should be inside the bracket. So I'm going to open another bracket. I'm having 1 plus. So this part here is a fraction, right? So easily, it's not be simplifying. Just use this, like this particular stuff. Display as fraction, then enter the numerator and denominator. Numerator, I'm having 0.06. Limit, I'm having 12. Initially, we open a bracket, Abby. So let us close it. So move it to the front and close the bracket. I didn't make it of the other bracket. As we went and do that like that, it will show no syntax error. So be careful of that. Open a bracket and you must always close it. I'm having raised power X, that's this power, then your shift and X, as simple as that. Then you can now move it to the back. Then you have your lower limit as 1, your upper limit as 24. Then equals to Boom, you can see our answer. That's 1,277.955,751. So currency most times is always approximated to two decimal places, meaning that here we are having 1,277.96, being read as 1,277 naira 96 kobo. So that's option C, as simple as that. So instead of applying the general formula easily, you can just make use of this. That's for annuity deal. Thanks for watching. Teamwork for